putting scale aside, okay? We have a vector, we have a Neptune documentation, and we want to write a chatbot that would be helping our users use Neptune. We, of course, Neptune is we, of course, can use, let's say, ChatGPT, but ChatGPT is not so well trained on our documentation or code base. How to connect it? You said that vector database can be used to kind of ingest knowledge to a model. What is a typical setup here?
We actually, if you want to see an example of exactly what you're talking about, Peter, in action, we have an application called OSS Chat. So it's OSSCHAT.io. And if you go to that website, you can actually see there's a lot of what we've done is we've indexed a lot of documentation for open source projects, both from the website as well as from GitHub. And you can ask and answer questions about the documentation. One of the first ones that we index is Milvus. And what ends up happening is if you ask ChatGPT or you ask GPT 3.5 or even GPT-4, how do I perform a query in Milvus? It actually gives you the wrong answer. It'll like hallucinate an answer for you. And if you ask OSS Chat, it gives you the right answer because what's going on is, I'll prompt it, how do I query in Milvus? And that prompt will get turned into an embedding. And all of my documents are also embedded into the same space. All of my open source documentation is embedded in the same space. And it will find the most relevant pieces of open source documentation. My vector database it'll return that at the application level. I'll return those documents along with the original prompt. And now what I have the capability of doing is with a bit of in-context learning, with a bit of prompt engineering, I can ask the LLM to focus on the results that I've returned from my vector database and use those results to answer the original prompt. Use those results to.
Would you say that it is kind of like, in theory, we could put into the prompt all those document pages, but of course we can't because prompts cannot be so lengthy and it would take forever. With vector search, with vector database, you can quickly figure out what are the most relevant pieces of information.
And by the way, this is called Retrieval Augmented Generation. This is exactly that, right?
Yeah, this is exactly Retrieval Augmented Generation. This is exactly Retrieval Augmented Generation. And we've built an example application to demonstrate that and to demonstrate what that potentially could look like as well. There are many forms of RAG, I want to be very clear, but the most common form of RAG, of Retrieval Augmented Generation, utilizes vector databases or utilizes vector databases in conjunction with other data stores. So, you can have these tree-based indexes. You could potentially use a graph database as a part of RAG, but vector databases are most commonly used. And the reason is, again, going back to the semantic properties of these embeddings, going back to the idea that, I have this prompt and I want to match the intent behind the prompt with the right documents. And what is so awesome about RAG with vector databases is, as my embedding models, as the models that I use to embed the prompts and the documents together into the same space, as those become better, my RAG application is I just snap my finger. I don't have to do anything, and my RAG application is going to become better as well, right? As my prompts become better, so is my RAG application. So really, I can improve all of this without writing a single line of code. I just improve the models and I improve the prompt engineering behind all of this, right? I have a better understanding of how these underlying large language models and embedding models work. But yeah, no, you're exactly right. This is exactly Retrieval Augmented Generation. This is exactly RAG. And it's the most common way to do it today is definitely with a vector database.